Okay, and now we are live sa ating Facebook page. And yes, we will be discussing the first topic for the second quarter. It's the projectile motion. So again, last quarter we end up discussing the triple motion, the one dimension. So for today's discussion, we will be discussing the two dimension, which is the projectile motion. The applications of projectile motion are limitless. No? We can, siguro nakakita naman siguro mga examples sa projectile motion. For me, the basic example of projectile motion is yung pag-shoot ng ball. It is in the form of projectile motion. Volleyball, as long as meron kang nakita na trajectory or in a parabolic form, that is a projectile motion. Takraw, also pa, pag-throw ng stone or ng isang bagay, and it will form a parabolic, no? I mean, a parabola form or parabolic in nature. That is a projectile motion. And also, as you can see, kanang ano po, kanang magdilig good kayo ng halaman. Yeah. Diba, the hose, diba, will form a parabola. That is projectile motion. Our knowledge of projectile motion, for instance, it allows us to determine safe locations, such as this example, staying during the pyrotechnic display. During Christmas, New Year, okay, if you are more knowledgeable enough about projectile motion, you know where to stay, you know where to find a safer place para di mo maigo sa fireworks. Watching a basketball, any sports, no, na naibola, it, yeah, it's still projectile motion. Well, lahat mo siguro, mas mga sports nga naibola nga dili projectile. Ba? Si volleyball with projectile motion, gihapon siya. Si basketball, si lawn tennis, table tennis, nag-form na ko projectile motion. Si, sa pamanaw, yung pag-serve ng ano, yung pag-serve ng shuttlecock sa badminton, di ba? Still in projectile motion. So may lain. Then, many examples talaga, napakarami. There are, I mean, limitless. So, in our discussion this afternoon, you will learn how kinematic variables interact during the motion of projectiles launched, specifically if there is the presence of an angle. So, what are the learning objectives this afternoon? At the end of the lesson, you will be able to first characterize the motion of both horizontal and vertical launching projectiles. Second, describe the motion of projectiles launched at an angle. Next, express the equations in determining the horizontal and vertical components of horizontally launched and launched at an angle projectiles in motion. And lastly, calculate unknown quantities in problems that involve projectile motion. So before we will start sa ating mga examples, the 1 hour discussion or siguro 45 minutes discussion is allotted to discuss the concepts about projectiles. Then the 45 minutes or 50 minutes is allotted to explain the process, no, of solving or getting the unknown variable, the case 1 and case 2 about projectile motions. So let me discuss. Let's have the conceptual part, of our lesson this afternoon. So when we say projectile means it refers to any object that has an initial velocity. Again, take note of this one. It refers to any object that has an initial velocity but proceeds through a parabolic path called trajectory. And it is entirely influenced It is entirely influenced by the acceleration due to gravity, which is negative 9.81 meter per second squared, and also the absence of air resistance. For simplicity, we treat projectiles as particles with constant direction and magnitude and constant acceleration, which is the acceleration due to gravity. So in projectile motion, for the x component, the constant is the magnitude and direction, which is the velocity. And for the y component, the constant is the acceleration, which is the acceleration due to gravity. Projectile motion is a two-dimensional motion. So our previous lesson tackled about free fall. One dimension lang yung free fall ha. When we say one dimension, it talks about only it's either x component lang or y component lang. In two-dimensional motion, it can be visualized. It can be visualized in an xy coordinate plane. There is a presence of x and y coordinate. Again, in projectile motion, meron na po tayong x and y components in which we can visualize it in xy coordinate plane or the Cartesian plane. In the projectile motion, the x component of your acceleration is 0. Kasi si x component, hindi mag-work ang acceleration due to gravity pag x component ng, the x component or the, anong tawag dyan? The distance of your x component. Pero the distance of your y component, there is an influence of your acceleration due to gravity. That is why the acceleration due to gravity of y is negative g, which is negative 9.81. That color blue na broken line, that is the trajectory, that is the parabolic path. So take note, projectile motion ta. So you will be expecting examples no na ingana ang figure niya. On the initial velocity. Take note ha, based on the definition sa projectile motion, there is already the presence of initial velocity. So an object's projectile motion depends on the initial velocity with the trajectory influenced by the acceleration due to gravity. It is a two-dimensional problem. Two dimensions. That means it has two components. The horizontal component at saka the vertical component. The horizontal component is the y. The vertical, x pala, baliktad. The horizontal component is the x. The vertical component is the y. Okay? Again, horizontal si x. The vertical component is the y. First, let's discuss the horizontal velocity component. Again, the horizontal velocity component. In projectile motion, the horizontal velocity component never changes. It covers equal displacement in equal time period. Ibig sabihin, the initial horizontal velocity is just the same with its final horizontal velocity. In other words, the horizontal velocity is constant. Again, in horizontal velocity component in projectile motion, the horizontal velocity is constant. So na ano? It's because gravity does not work horizontally to increase or to decrease the velocity. Again, gravity does not work horizontally to increase or to decrease the velocity. That makes the horizontal velocity in projectile motion constant. Ibig sabihin, from initial velocity to final velocity of horizontal component, they are the same. They are equal. They are constant. Meanwhile, pag vertical naman, dito na mag-change. Okay? So vertical component, it will change. It will change because of the presence of the acceleration due to gravity. It does not cover equal displacements in equal time period. Take note of this one. Both the magnitude and direction change. So as the projectile motion, as the projectile moves upward, the magnitude decreases and its direction is going upward. Meanwhile, if the projectile it will move downward, the magnitude increases and the direction is downward. Based on our previous lesson last time, what do you call this one? Wait lang, nawala. What do you call this one? Ito. Ito naka-highlight ko dito. What's this? I've discussed this one already. Ito na siya. Okay, very good. Sabi ni Andrea, it's the peak point. The turning point, the peak point, the highest point. Okay, that's correct. Sabi ni Andrea. Now, let me ask you, what's the velocity when the ball or when when the ball or anything na mag-reach sa maximum point or the peak point, what's the velocity? Okay, very good. At least naka-remember mo sa previous lesson natin. Again, if you are going to throw a certain thing and then mag-reach siya sa maximum point niya or the turning point, the velocity is 0 meter per second. Then the velocity is 0 meter per second. If the thing or the ball will reach to its maximum point or the turning point. Sir, paano mo nasabi dito that the magnitude or the velocity in this vertical component as the direction is going upward, bakit mag-decrease siya? Based on the definition, in projectile motion, it must have the initial velocity. So for example, if the initial velocity here, example lang niya, if the initial velocity here is 21 meter per second, so as the ball is going up or as the ball is moving upward or going upward, of course, pagdating sa turning point, it will become 0. That makes it, nag-less siya. Ibaba siya from 21 to 0. So that's the explanation that as the projectile moves up, the magnitude decreases. So from 21 meter per second, moving upward, it becomes 0, so it decreases. Meanwhile, pag pabalik naman siya, as it moves downward, okay, from 0 to 21 meter per second, example lang tayo from 0 to 21 meter per second. So from 0 to 21, it increases. So as it moves downward, the velocity increases. However, the direction is going down. So that means your velocity in that case is negative. Again, the velocity, your magnitude or velocity on that case is negative kasi the direction is going downward. Now, let's have this kind of scenario. We have these balls, red balls and yellow balls. So consider a ball undergoing free fall. So see, yung naka-red na ball, it's just a free fall. And then yung yellow ball naman, okay, it's undergoing projectile motion. Ito yung sinabi ko kanina. A projectile is an object whose motion in the absence of air resistance consists of horizontal motion with constant velocity and vertical motion with constant acceleration. Again, in projectile motion, it consists of horizontal motion with constant velocity. The magnitude, the direction is constant. Meanwhile, in vertical motion or vertical component, the magnitude and direction changes. However, the acceleration is constant. So to summarize, no, yung binanggit ko, makita niyo dito sa table na present ko. For the horizontal component, the magnitude and direction is constant. In vertical component, the magnitude and direction changes. However, the acceleration is constant. Again, in horizontal component, the velocity is constant. In vertical component, the acceleration is constant. Okay, let's continue. So what are the things that we need to consider if there is a presence of an angle? A projectile motion launched at an angle. Ay, possible guys, sir? Yes, if you are going to throw a ball to the basket, di ba? Kung mo siyang i-measure, there is an angle talaga. May presence of angle talaga yan. So what if mayroong presence ng angle? So one of the most crucial components of projectile motion is the launch angle theta. There is a presence of an angle. So of course, once there is a presence of an angle, it influences the height, the range, and the duration. Duration means the time of flight of the projectile. And also, since it talks about vertical component, the gravity acts on the projectile launched at an angle. Present gihapon si acceleration due to gravity. Mabitaw no, kung musot ka og bola, of course, moadto sa ground. Lain po kay maglupad ang bola no. Wala man ta sa moon, wala man ta sa gawas. I mean, wala man outside sa earth. Naman ta sa earth no. So because of the presence of the acceleration due to gravity, pag iitsa nimo ang bola, mubalik din sa pababa. Okay? Because of the gravity. So in this situation, because of the angle, because of the presence of the angle, maapektuhan po ang atong acceleration to gravity. Example to this is ito. Consider a cannonball fired at an angle. So example lang tan, may angle din na form, no? Yan. So, of course, it forms a parabolic in nature, no? May trajectory na may tabo, parabolic trajectory. Lain po kaayon, no? Nabalik cannonball nga, dili mo sa ground ang bola. Naglupad ang bola. So, of course, moabot siya sa ground because of the gravity. So, it goes up at a certain height, then it goes down because of the gravity. Okay? It accelerates vertically due to gravity. So, how do we calculate it systematically? Murag same lang ang atong buhaton no, since there is a presence of x and y components. So, we will solve no the velocity of x component and velocity of y component. And I've discussed that one already. Na pag x component, the trigonometric function that you are going to use is cos. And for the vertical naman component, you are going to use the sine. And make sure that the mode, no, the mode of your calculator is naka degree mode. Eh, mo bito mamali mo no kay naka radian mode in yung calculator. So make sure lang na naka degree mode siya. So in this figure, the green arrows indicate that the initial velocity of the projectile, yun yung green arrow. Green din sir. Yeah, colorblind mo. Then the light blue arrows, it shows the components of projectile's velocity at a certain point. The x component and the y component. And the velocity along the horizontal component is constant, and it is signified by the length of the arrows along the x-axis. Sir, unsa ning r dire? This r means the range. R or dx. Kasi ba sabot sa d? It's the distance of the x component, no? I will discuss that one later. So r or d of dx. The object goes against gravity as it heads upward, causing the velocity along the vertical to decrease until it reaches zero. Okay, that is why, di ba, pag abot niya sa turning point, the maximum point, the velocity here is 0 meter per second. And also, the projectile will be influenced rather solely by gravity, and it will accelerate downward. So let's discuss the descriptors of motion of this. Descriptors of projectile motion. First, the duration of flight. When we say duration of flight, that's the time. The duration of projectile's flight, it refers to the time it takes the object to reach the surface from the time it has been launched. Kung sa Bisaya pa, kung asa siya the time kung asa siya nagsugod, kung asa siya nag-end. The duration of flight. We also have the maximum height. The maximum height or the dy. Wait lang, ayan. dy. dy niya, kung natin dx, so dy. Pero dili ni calculus ha. Dahil itong dy over dx sa calculus. So the maximum height or the dy, the distance of y component, that is the projectile's maximum height. It refers to the point in which the velocity is equal to zero. The point in its trajectory when the velocity along the y-axis is equal to zero. Kung asa ganito mag-zero ang velocity, that is the the distance, the distance from the ground to the point, to the maximum point, that is the maximum height. Kung baga pa sa drawing, kung mauni ang drawing, then mo na yung bola, projectile motion. Example lang ha, an example. If this is the turning point or the maximum point, and this is the ground, ang distance daan niya is this is the maximum height. Or, yung sinabi ko, it's the dy. Okay, height or the maximum height of the dy. The last but not the least, we have the range. So range refers to the projectile's horizontal displacement. Or yung sinabi ko kanina is the dx, the distance of your x component. Or should I say, the horizontal displacement. So sir, pasabot ka ng horizontal displacement, sir, naagya po si direction. Malamang, displacement has magnitude and direction. So upon solving, you must consider asa pagdulong ang bola. It is going to the left ba siya or going to the right? Kasi pag going to the left yung ball, yung horizontal displacement must be negative. If it is going to the right, your horizontal displacement must be positive. In this equation, if we are going to draw this one, ito yung bola natin. Yan. This one, this area, this is your D, this is the horizontal component. That's the range. Kung asa, gikan na launch ang ball, hangtod moabot sa mobalik sa ground. Again ha, always din na siya mobalik sa ground, no? Oh. Because of the gravity. Sige daw, ambak, sorry. Ayun na eh. Try daw mo ano, ka nang maglabay og bato. Diba? Lain pag ang bato maglutaw. Na mo sa outer space, nata sa earth. So, mababa din siya. So, if you're going to throw a stone from this point to the other point, that range, no, or your horizontal displacement, that is the range, no? Kung asa ka nagsugod og labay bato, hangtod asa naabot ang bato. That's the range. Take note, a projectile's trajectory consists of both horizontal and vertical motions with constant velocity and constant acceleration. Keep in mind that these two components, both horizontal and vertical, they are independent of each other. Okay? Hindi na sila nakaka-affect with each other. And before we will proceed to the solving part, let me introduce to you the three cases of projectile motion. Okay? Before tayo mag-proceed to solving, let me present to you the three cases of this projectile motion. Sige, so yeah, the first case no, is the ground level case. Let me remind you about this ground case level. Here, the time from the start is the time one. Okay, the time from the start here, at saka from the time, sorry, the time kung asa siya gi-launch to the maximum point, at saka the time from the maximum point kung asa siya mabalik sa ground, time 2, they are equal. Parehas lang. Again ha, in ground level case, T1 is equal to T2. Mauni ang nahitabo sa inyong quiz last time, quiz 3. Naiinga nga situation, wala ninyo get times 2. Okay? Si elevate horizontal, kani siya, igo na siya pababa. Kaning si elevate horizontal, mura siya kaning half sa ground level. Again, si elevate horizontal, mura ni siya same sa ground level pero nakatunga lang ni half. Pero si elevated angle, if this is the maximum point, ang time ani is not equal to time 2. This la equal. Again, si time 1 is not equal to time 2. Because iba yung time dito, iba din yung time pababa. Considering na nandito siya na-start. Okay? That's the explanation. I think we should have a break first. I will give you 5 minutes, no? Mag-break sa ta ha? 5 minutes. 5 minutes break. And I will present the first example. This one again. I present the first example and let's have our 5 minutes break. I will be right back by 2:15 and let's start discussing our examples. And also pag ano mga practice mo solving ha, maminaw ta ha kay face to face ang kanina quiz. Again, face to face ang kanina quiz. So maminaw. Okay, I think we should start. It's already 2:15 in the clock, no? So let's have our first example. And yes, I already presented our first example. And if you are going to draw this one, what case ang mako-form? Again, if you are going to drawing ninyo ang case kasi mako-form yun yung case. Kung sa man na case class, case 1, 2, 3, kasi ma-form. Okay, very good. It's case 1, no? Now let's proceed to our virtual whiteboard. So please take down notes and please listen sa discussion natin about these examples because lalabas ito sa exam. Ay, exam sa quiz. Face-to-face ang quiz na to, aning ha? Sige. So, a ball is launched from the ground. Take note from the statement from the ground. So, nag-start yung bola natin no, sa ground. Here. From the ground at an angle of 60 degrees. 60 degrees with the horizontal and with the horizontal at an initial velocity of 30 meters per second. So siguro ang bola kay gikik siguro ni siya no, kung nalagpot sumuni ang na-form mga bola. Then ibalik sa ground. The initial velocity is 30 meters per second. Yan. Then, this one, anong tawag natin dito? Initial ha, di na final ha, wait lang. Ano, erase. Yan. Study class, this is the maximum point, diba? This is the, what do you call that one? This is the turning point, the maximum point. This is our final velocity. And that is 0 meter per second. And this is our dy, okay? That's the maximum height. And this one is our range to the x. From our given situation here, letter A. Anong ginahanap ni letter A? Anyone? Ano ang ginahanap ni letter A? It's the, okay, very, very good. It's the dy. Ang ginahanap ng letter A is the maximum height. It's dy. Now, my question is, among the formulas I presented earlier, there are four formulas there. So, what is the appropriate formula natin gagamitin to solve letter A? What's the formula to solve letter A? It's the, okay, very good. It's the third formula. Agaray, nawala ko. Ala, di ba na-remember ninyo pag mawala ako kay back to zero? Oh my God. Wala ko yung choice. Sige. Kasi kita kung di ba mutahan kaya si Gregorio, no? Gregorio nga no, gani Gregorio nga nung third formula atong gamiton to solve for letter A, Gregorio.
Kasi ano sir, hindi given ang time tapos ang hanapin ay given naman ang initial velocity and final velocity and we're looking for the dy po sir.
Okay, thank you so much. So we will use the third formula. You're correct, no? So the third formula is dy. Sorry, mali. 2g dy is equal to final velocity of y component squared minus initial velocity of y component squared. So karon, naman tayo ginatawag na x component o y component. Yeah, sir, ang given lang mo natin is the initial velocity which is 30. So we need to and also the angle pala. The given also is an angle, no? Okay. Here, i-drawing na ko usab ang ang situation, i-drawing na ko usab. And the ball. This is 60 degrees, no? The initial velocity is 30. The turning point here is the maximum point. That's the final velocity of 0. And this is the dx, the range, and this is the dy. So we need to get first our initial velocity of x component, the initial velocity of y component, and also the final velocity of x component and the final velocity of y component. Walay problema sa final velocity because they are automatically zero. Again, they are automatically zero si Bfy. Diri naman is Bfx cos 0. Cos 0 is 1. So Bf. So dito naman si x component, initial velocity cos theta. Initial velocity sine theta. So 30 cos 60 degrees. Pila ang 30 cos 60 degrees? Pila man? 30 cos 60 degrees. Pila answer? 30 cos 60. Pila answer na to? It's 15. 15 meter per second. And also, how about the 30 sine 60 degrees? 30 sine 60 degrees. Pila? 30 sine. Kopyata na na, kapitalan ang nasa calculator. Thirty sine 60 degrees. Uy, ilan sir? It's 25 point. Basta I am sure that that is 30. That's 15 square root of 3. Okay? Sir, explain daw sir, anong kaniyang answer sir? So in this situation, sa turning point class, sa turning point, the angle is 0. Again, in the turning point, the angle is 0. That is why final velocity cos 0 unang answer. Ito din, final velocity sine 0 mauna ang answer. Kung 0 of Vf ang pagutang. Cos 0 is 1, sine 0 is 0. So, ang importante lang man dito, no? Kay ang VIY o ang VFY. Excuse me. Ano lang yung dalawa yung gagamitin natin to find our maximum height. So, i-substitute natin 2 times the acceleration due to gravity is negative. Again, the acceleration due to gravity is negative 9.81 dy. Our final velocity of y component is 0. Then, our final velocity of y component is 0 minus the initial velocity of y component. Sila itong initial velocity of y component. It's, dara, kapag sulat no, so, paste na lang ako, ha? Here. Hindi. Nasa kapulan akong sulat. Okay, so this is the initial velocity of y component. I-multiply daw, pila answer ani 2 times negative 9.81. That's negative 19. Multiply, negative 19 point. Pila? Okay, na natin 262 dy. Then 0 minus squaredly. The 15 square root of 3 squared, that's 225 times 3. That's pila? 600. 15 square root of 3 squared. Or yan, 675. Yeah, that's 675. Okay, 675. Then simplify, negative 19.62. Then the maximum height dy is equal to negative 675. So sa next step, ano class? You are going to divide both sides by negative 19.62. Divide both sides by negative 19.62. And your dy now is, ilan dy? Our dy now is, okay, it's 34.403 meters. Apply significant figure. Again, apply significant figure. The answer. Apply significant figure based on our given. There are 3 significant figures, diba? I mean the number of significant figures is 3 rather. So apply significant figure. So our final answer is 34.4 meters. And this is the answer for our first problem. This is the maximum height. It's 34.4 meters. How about letter B? Letter B is asking how long will it for the ball to reach the ground. So from the start daw, nag-launch ang ball up to mubalik ang ball sa ground. Pila daw ang time. So, time ang ginapangita for letter B. Then, time ang ginapangita for letter B. But my question is, among the formula, the 4 formulas I presented earlier, what is the appropriate formula in order for us to get the time? Anyone? Kasi formula kang gamiton. Okay, so, sabi ni Vali at saka ni Gregorio, ni Ethan, ni Rafael, second. Ay, si Ethan sabi niya fourth. Ito na lang nalahig chat, no? Si Rafael kay second. Hoy, asa na rin ako mga estudyante di ay. Kapoy na mo? Oo, laban ng modera, no? Sabi ni Lord, kay second formula daw. Pangutangan sa ka, Lord. Yes, Lord Michael. Bagyo. Lord.
Hello, sir.
Bakit second formula ang gagamitin natin?
Kasi sir, ang
Kasi formula.
hinahanap po sir kasi ay acceleration
Ano
is
pala?
equal to final velocity minus initial velocity over time sir. Tapos given naman yung ating initial velocity sir. Ay, ambot sir. Tapos ang final sir kasi pwede man siguro 0 sir since parang ano man sir. Mag-stop man siya sir.
Mhm.
And then ang acceleration sir kasi gravity sir. Ngayon siyang gravity.
Thank you. So according to Lord, you can use the second formula. Actually, the second at saka the fourth formula kay pwede sila gamiton. Again ha, take note of this one. Pwede si second formula, pwede si fourth formula ang gamiton. So nga kung pwede si fourth. Pwede si fourth formula ang gamiton, it's because nakuha na natin yung dy, na-solve na natin yung maximum time. Then, pwede si fourth formula ang gamiton because na-solve na nato ang dy. Si second formula, siya ang ato ang pwede gamiton po. Pero, to tell you honestly, mas dali gamitin yung second formula kaysa sa fourth formula. So, in this situation, mapa-second or mapa-fourth formula, they are the same. They will arrive the same answer. So, para mas dali sa ato, para mas dali siya i-solve, to get the time, we will use the second formula. The formula is acceleration due to gravity is equal to final velocity of y component minus initial velocity of y component over the time. So this is the formula that we are going to use to get the time. Mas dali siya gamitin compare sa fourth. Applying algebra manipulation or the formula manipulation, this will be the new formula. Ano lang natin, i-manipulate lang natin yung formula natin. No? Sorry, G pala dyan. So let's substitute. The time is missing. The final velocity for y component is 0. Tama, di ba? 0. The initial velocity of y component is 25.9807. Then, over the acceleration due to gravity is negative 9.81. So, we have here, yeah, the value is negative, no? Negative divided by negative 9.81. Kindly answer, what's the time? What's the time? Mhm. It's 2 okay, very good, no? Very good. 2.648 something. Yeah. That's the time. Negative divided by negative is positive. Okay? Negative divided by negative is positive. But class, take note of this one. Ano yung sinabi ko kanina pag case 1? That the time 1 and time 2 is equal. Diba may sinabi ako? That the time, no? The time from the ball, no? Where it is launched, papunta dito, is the same time with the maximum point to the ball papuntang ground. Yes, that's correct, Andrea. You need to multiply it by 2. Kasi from the question, how long will it for the ball to reach the ground? Ibig sabihin, starting from launching the ball up to the ball, up to reaching the ground ulit. So from this to this, from kung asa siya nag-start up to pabalik sa ground, that's the total time. So tama yung tanong ni Andrea, no? It times 2 pa ba siya, sir? That's correct. It times 2 nato siya. So in this situation, the total time, no? The duration is 2 times this one. So what's the answer? Multiply natin. 5 point 5.2968 seconds. Apply significant figure. The number of significant figure, no, the least number of significant figure is 3. So what must be the final answer? Applying significant figure, 5.30 seconds. So this must be the answer. Again ha, only case 1 lang ang pwede mo mag times 2 if hahanapin yung time starting from launching up to the ground ulit. So kailangan nyo siya i-times 2 to get the duration of the flight. So i-times 2 siya. Sa case 1 lang na siya applicable ha. Sa case 2, di siya pwede ma-apply because case 2 is just the half of case 1. And also in case 3, iba yung time ng isa sa time ng isa. Hindi sila equal. So in the situation, i-times 2 siya. Mo ni ang nahitabo ato inyong quiz last time, wala ninyo gi-times 2. Again, hindi niyo siya gi-times 2. And that's the reason why wala daghan na mali dito na problem. Sige, so kindly copy before we will proceed to our third example. Okay, copy muna before third example. Letter C. If you have questions, you can raise right now. And then if you have clarifications, concerns, you can raise right now. Yes, Lord, you are raising your hand, Lord.
Ay,
Have
sir,
any
so every time na mag-solve ng time or ano, sir, or distance din, sir, kinag-apply din, sir, dapat i-times 2 lang, i-times 2 sa para sir. Kaya parang half lang ang masolve, sir. Ngayon, sir.
asa ka? Atong sa asa? Sa
Ay,
asa
dito, sir,
doon?
ba kasi parang, so parang walang other way, sir, na parang madiretso mo siya masolve, sir. Half-half talaga para sir.
Eh, pwede naman siya butang, pwede naman siya i-times 2.
So, times 2 yun siya. Ay, okay.
Okay, ang situation man good Lord, ang giingon mo ko sa situation kay how long will it for the ball to reach the ground. So, nag-start siya sa ground, gi-launch siya or gisipa ba siya, then bumalik siya ulit sa ground. So from initial position niya to its final position, which is the ground ulit. So that's the total time. From the time, no, from the initial point to the maximum point, then from the maximum point to the final position, final point. So you need to multiply it by 2. And that is for case 1 only. Case 1 lang siya situation na kung mag-times 2. Pero sa distance, dili siya i-times 2 ang distance, Lord. Sa distance, Lord, kay ay sa murag feel na ako murag si letter C imong kwaon, no? Mo ba imong isa sa mga gusto i-point out for letter C?
Ambot, sir.
Ha?
Ambot, sir. Pero sir, yun, sir. Gets ko na, sir. Thank you, sir.
Sige. Yes, Rafael, constant na yung y sa lahat ng equations. What do you mean by y, Rafael? Yung y na nasa formula?
Ay, yes, sir. Yung rest dito sa letter B, sir, kay VFY minus VIY, sir. Constant na yung y, sir, sa lahat ng equations.
Yes, nasa sa formula. Di ba na-present sa formula later na. So, kato lang ang formula inyong gamitan.
Okay, sir. Thank you, sir.
Okay. Now, let's have letter C. Yeah, we will solve letter C. No, then let's proceed to our last example. Si letter C, how far does the ball reach from where it is launched? So, ang gipangutana ni letter C is the range or the dx. Mo nang ginahanap natin for letter C. The distance from the initial position of the ball, kung asa siya gilaunch, to the final position of the ball. So, from this point to this point. That's the range. Yun yung ginahanap natin for letter C. So, dx ang ginahanap natin for letter C. Again, dx ang ginahanap for letter C. So, how far does the ball reach from where it is launched? So, you need to understand. You need to comprehend talaga the problem, no? Kasi yung gusto niya, what is being asked. So, let's solve for letter C, the formula. What's the formula that we are going to use? dx or r yung hahanapin natin. So, the formula that we are going to use is dx is equal to, sama yung formula? The first formula. The first formula. Marami ito yung dx, diba? The first formula lang ito yung dx. So, ano yun? Vi x times time. Then, Vix times time. So, substitute lang natin our Vix based on our previous problem. This is the Vix. Vix means the initial velocity of the x component. Then, Vix means the initial velocity of our x component, which is 15 meters per second. And our time is, ilatong time? Ang atong gamito na time is the total time, which is 5.30. Again, the total time ang ato ang pangitaon. Sir, nga si total time ang pangitaon, sir? Of course, from the question, you need to get the distance kung asa siya nagsugod up to asa siya nag-end. Kani nga time, kani si 5.30 seconds, this is the time kung asa po siya nag-start, di ba? The time na kung asa siya nagsugod up to asa siya nag-end. That's the 5.30 seconds. So, dapat same sila ang para atong time na ganito. Then multiply, what's the answer? 15 times 5.30, 45 plus 45. It's 15 times 5 is 75 plus 45 is 79.5. Am I correct? 79.5. Yes, that's correct. 79.5. Then of course meters. This is now our horizontal displacement. Again, this is now our horizontal displacement. Question? Di ba napansin ninyo na you cannot solve letter C pag dili mo ma-solve C, B. Di ba they are related? So they are related. So you need to make sure talaga na kailangan mo ma-solve yung una bago mo ma-solve yung pangalawa, yung kasunod na. So, kindly copy muna before we will proceed to our last example. So, the last example is medyo, tricky konti yung last example natin. Copy muna kayo. So let's proceed to our last example, no? Let's have our last example, and I want you to solve this one. I will give you around 5 minutes to solve this. 5 minutes lang, then I will solve them. I will present my tools. Try to analyze what case is this, but again na lang, let me give you a clue. Let me give you a hint or clue that this case is case number 2. Again, this is case number 2. So I want you to think, to analyze what could be the best solution to answer the problem. Okay, so I will give you 5 minutes to solve this. Yes, Sir Rafael Rubigan. Yes, that's elevate horizontal. Kumbaga pa, ang yang angle is 0. That's the half of the case 1. Finally solve. If you're done, kindly chat your answer. What is the initial speed? Medyo lisod siya, no? Because ang given lang po natin is the dx, which is the horizontal displacement, and the dy, which is the vertical displacement. So, as you can see, murag napaisip kayo good no na, saan man siya, saan man siya. Kasi, hindi given yung time. And, you cannot find you cannot use the third formula because hindi man given yung final velocity. So, yan. Ang gagawin niyo muna dito to solve this problem, you need to get the time first. Again, you need to get the time first. Sir, kung saan man ipag-solve? Sige, let's solve this one. Okay, at ato na siyang i-drawing, ha? And of course, don't mind my drawing, no? Because you know na, dili ko how mag-draw. Again, in the problem, it was stated here, a missile must be fired horizontally off a 120 meters hill. So that naatay hill na nataw hill, no? Model ni hill. Sa hill ni siya. Tapos plus, naay missile diri. Naay missile. Basta missile na siya, ha? Missile na. Kamo na magbuot. Kamo na mag-adjust na missile na siya. Uy! Hindi ko ako yung missile. So yun, missile baka man sir. Missile daw na siya. And then, na the warship. Okay. Take note that the distance, no, from the hill to warship daw, ay dagat mo daw ni. The distance, no, from the hill to warship is, sir, mo ni mo warship? Wala mo choice class, mo na kaya na akong drawing class. Mo warship sa unang panahon. Okay? So, the distance is 25 kilometers. This 25 kilometers, convert that one into meters. Sir, anong kailangan natin i-convert into meters? Take note that you need to consider that the unit, no, should be in SI, no? Naka-SI dapat yung unit natin. So, 25,000 meters. And this is your, saan na siya? 25 kilometers or 25,000 meters. Saan na siya? That is your dx. Again, that is your dx. And then the height of the hill is your dy, which is 120 meters. Again, the height of the hill or the dy is 120 meters. Karon, ang giingon diri, you need to, it will hit a warship of 25 kilometers away. So, mo daw ni ang bola sa missile, no? Kailangan daw niyo maigo ang warship. Dapat maigo daw siya. What must be the initial speed? So, mo ni ang gipangita. What must be the initial speed para maigo ang warship? Initial speed sa missile para maigo ang warship. Now, dy and dx is given. So, take note, this is case 2. Again, this is case 2. So, the angle in case 2 here is 0. 0 ang angle, ha? So, to find the VIX, Vi cos 0. And for the y component is Vi sine 0. By the way, cos 0 degree is how much? What's the value of cos 0 degree? Cos 0 degree? What's the value? It's man. Okay, that is the correct. It's 1. So cos 0 degree times, that's 1, no? That means the value of your initial velocity of x component is the initial velocity itself. Again, the value of your initial velocity of your x component is the initial velocity itself. How about sine 0? What's the value of sine 0? Okay, that is the correct also. It's 0. If you are going to multiply the initial velocity by 0, the answer is 0. So, the initial velocity for y component is 0. Let's continue. Now, let me ask you about this one. We need to solve for the time first. Okay? Kailangan muna natin i-solve yung ha? Pag ganito na problem, you must solve for the time first. So the appropriate formula na ating gagamitin to solve for the time in this kind of problem. Ang formula natin gagamitin to solve for the time here is what? The fourth formula. Hindi pwede gagamitin ang wala may time. Fourth. Si fourth ang atong gamiton. Okay? Si fourth ang atong gamiton. Iyan na si fourth. Kasi, ang naalay time dito, di ba, first, second, or third. Si first, dili pwede magamit kaya wala pa initial velocity. Si second, dili pwede kaya wala tayo final velocity. So, the most appropriate formula in order for us to find the time is the fourth formula. So by using the fourth formula, we can now find our time. What if kaya no i-derive na ako no? Bitanong what if mag-derive ng formula ba? Ano kung the same situation lahi lang ang given pero pangita ko ng initial velocity. What if kaya magbuhat ko ana? Di ba? Well, di na mo gana ako mouse plus. Oh my God. Wala, di na siya mo gana, class. Dili daw ko pag gamit. Wait lang ha. Di na mo gana ako ang mouse. Wait lang, class ha. Dili nagagana akong mouse. Wait lang, yun. Okay, okay. Let's continue. Murag nagana na siya gamay. Sige. Again. Asa ko nag-end? Sige. We will use, no? This formula to get that time. Ala, patay, di na po siya mo. Oh, di na po siya mo gano'ng class. Oh my God. Ako na na-stress. What's our dy? Our dy is what? Our dy is, it must be negative. Pura, Plus, isod kayo, wala yung mga wait lang yun. Gana naman ako. It should be negative 120. Again, it must be negative 120 para makancel na to ang negative later. Ha? Ay, Diyos ko, Lord. Wala to ba ang battery? Palas, anong mouse ako eh. So, anyway, wait lang. Salamat. Uy, thank you, Lord. Medyo na okay, nakita ko battery. Sige, it must be negative 120. Yan. Kasi pag dili mo siya ay negative, ma-negative ang imong square root later. Again, pag dili mo siya ay negative, ma-negative ang imong ma-square root. So, wala yung answer. Ang isa pagka-reason, pababa ang bola. Again, pababa yung bola or yung missile. So, the distance must be negative. The direction must be negative. The initial velocity per y component, pila value ani? The initial velocity per y component, what's the value? It's 0. Times time plus 1/2 times g. G is negative 9.81 meter per second squared times time squared. Okay? But actually, this formula, applying algebra manipulation, we can use, we can have this formula applying algebra manipulation. Its time is equal to square root of 2 dy over the acceleration due to gravity. Again, from this formula, we can use this formula no applying algebra manipulation lang or formula manipulation. The same lang yato sila answer. You can use this formula actually. Kung time ang ipangita. Kanina formula, it was derived, no? It was being derived from the fourth formula given that your initial velocity of y component is 0. Again, this formula is getting the time or solving for time given that the initial velocity is 0. Initial velocity for y component. So let's continue. Negative 120 meters is equal to 0 minus 4.905 meter per second squared, then times squared. And then negative 120 meters is equal negative 4.905, then meter per second squared times squared, and you must divide both sides by negative 4.905. Again, you must divide both sides by negative 4.905, this one. Cancel, cancel. So the time here, T squared is 120 over 4.905. Wala nang negative ha, because negative divided by negative is positive. Again, negative divided by negative is positive. So here, extract the square root, extract the square root. What's the value of time? The time is, answer. Ila tong time? Pag-solve na to, ani, ila tong time? 4.946. Yan, seconds. Apply significant figure. Apply significant figure. What's the answer? Two significant figures. Sorry. 3 or 2? Two significant figure. Two significant figure. It's 4.9. Two significant figure, 4.9 seconds. This time, since na-solve na natin yung time, okay? Na-solve na natin yung time, so we can now find our initial velocity. The formula that we are going to use is the first formula. Vx is equal to initial velocity of x component times time. Again, we can now solve for our, the missing or the answer. So, dx, the x component or the horizontal displacement is equal to the x component of initial velocity times time. So, dx is 25,000 meter per second. The initial velocity of x component is initial velocity. Asa man ta nangawat ani? Again, the initial velocity of the x component is ani. Asa man ta nangawat? Galing dito. Tara. Diba? Galing siya dito. That your initial velocity of x component is the initial velocity. So galing siya dito. And our time is 4.95 seconds. Ay, wait, mali akong unit. Mali. Sorry. Yan, wala pala yan. Sorry, mali ko. Nabutangan ako unit. 4.9 seconds. Again, 4.9 seconds. Then divide both sides by 4.9 seconds. 4.9 seconds. What's the answer? Your initial velocity is ila? 25,000 divided by 4.9. Apply significant figure. Yes, apply significant figure. What's the answer? Apply significant figure. Ilaman, 5,100 meter per second. Again, the initial velocity is 5,100 meter per second, applying significant. So that's the answer. Siguro class no, mag-derive ko ang formula para sa inyo ha. Para ang inyohan na lang isulat, no? Ang inyohan na lang isulat kay kaling mga given lang na murag di na ninyo pa ng time. Gusto ninyo mag-derive ko formula na di na mo magkuha time, like diretso na siya. Gusto mo ka ng input na lang ninyo. Sige, try na to mag-derive ko formula ha. Let me derive a formula for you. Basta that's the process of the answer. 5,100. Ang kinahanglan lang ninyo, again, ang need nyo lang good is the initial velocity of x component, the dx, Moral yung need class. Moral yung need. Kung mag-derive yung formula, moral yung need. Ito, dx, dy, o ganun. Moral yung need. Sige. Let me derive it for you. Again, let me derive it for you, ha? Sorry, guys. So, magunaw na sa kuha sa pag-derive. Muna yung formula sa fourth formula, no? Wait lang. I-derive sa nako ang formula. Ay, mali. I-try daw ninyo solve ni class. The same lang bag-answer. Muli ang formula natong gamiton. Natong gamiton formula. To find the initial velocity, the given are ang dx kay 120 meters, ang dy kay 25,000 meters, ang acceleration due to gravity is negative 9.81. But anyway, the dx here is negative 120, ha? The dx here is negative 120. Try to solve daw if the same ba ang answer. Ay, ma-positive na siya. Wait lang. Wait lang, ha? Mas negative. Ayan. Ay, sorry. Mali ko, mali. Namali akong given. Sorry, namali akong given. Sorry. Ang dy ang negative 120. Yan. Namali. Ang dy ang negative 120. Kindly solve daw. Naya akong answer. Naya akong ano ngayon. Ito mali sa formula. Wait lang ha. 25,000 divided by yeah, I think this will be the most accurate. Okay? This is the formula. This is the formula na most accurate ang answer. Oh, bakit 31 inyo ha? Naka-squared ha, naka-squared akong answer kay 5,054. Again, my answer is 5,054. Try to recheck. Ang dy kay negative 120. I think this is more accurate than yung ganina na solving. So, sige. Pag maka-encounter mo ang same problem sa case to nga ingatong situation, again ha, pag maka-encounter mo na ang given lang kay dx of dy, mo na lang inyong gamito na formula. Again, apply significant figure para na. Again, apply significant figure. This is 5,100. Huwag ka mo lang ata na section ako nga derivative formula ngayon. Again ha, kung same problem. Again ha, ang pangutana, kung same problem lang. So, giderive na ko ang formula para sa inyo ha. And I found it more accurate compared sa nasolving. Okay, so wait lang ha, mo attend sa kong meeting. Sige, question? Basta mo ang formula. Di ba, ang atong problem kay gipangita ang initial velocity. Tapos, wait lang ha. Sige, balik na ako sa Rafael. Dara. Di ba tanawa ang problem? Ang problem lang is pangitaon ng initial velocity. Then, ang given lang is dy o dx. Di ba? So, again, you can use this formula. D squared x, no? Naka-squared siya, no? Ang atong x, ang horizontal component, then 2 dy. But for me, this is more accurate formula. Kung similar situation. Again na, kung similar situation. Questions you can raise right now before we will end. By the way, the case 3 of projectile motion, no? I will post a video of Sir Carmelo discussing the case 3, and you are required to watch that video. And there will be a practice test also, and you are required to answer the practice test. The deadline for the practice test together with the video, no? November 8. Ay, 7 pala. Sa inyo na case November 7. Kasi you will be having your face-to-face quiz this coming November 7th. Okay? 8 pala, sorry. 8. You will be having your face-to-face quiz this coming November 8th. One of the coverages, no, of your quiz, first quiz for this quarter is itong projectile motion. So you need to watch the case 3 kasi sa inyong quiz, isang problem case 1, isang problem case 2, at saka isang problem case 3. May additional pa, Andrea. We will discuss the laws of motion this coming next meeting. Yeah, this coming Wednesday, we will discuss the 3 laws of motion. So apil pa sa ila sa quiz. So yon. I do hope na nakinig kayo nag-meeting mo sa faculty karon pero magklase gihapon ko. Oo. Yeah, nag-meeting me regarding sa next this coming November, what will be the plan of the administration regarding the classes. Kung full-blown ba or same lang gihapon. But for me, mas okay man siguro kung nani. Pero, you know, to tell you honestly, I prefer na mag full-blown. Kaya mas okay man good na mag face-to-face discussion. Diba? Kasi prefer niyo face-to-face discussion o ingani nga online discussion? Sarot. Yes, face-to-face discussion at the same time face-to-face ang assessment. Hindi ko masagot na i-online ang assessment. Sige, but we will wait for the decision of our administrators. So we will wait for their decision. Sige, so it's almost 3:30 in my clock. No? So let's have our closing prayer to be led to us by nasa si Santor ba? Blazy. No, wala si Blazy. Gitulugan ko ni Blazy.
Hi, sir.
Kinadi, ay sorry.
Madunggan
Blazy.
ko.
Yes, lead us with the prayer.
Okay, wait lang. Let us put ourselves in the presence of God and the Father, the Son, the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, the Son, the Holy Spirit. Amen.
Okay, thank you so much, Blazy, for the prayer. So once again, before we will end, I am requesting muna everyone, kindly turn on your camera for documentation purposes. And by the way, sa dili ang okay, na concepts mo gawa sa quiz, napod tayo solving. Again, ang solving case 1, case 2, case 3, similar cases lang ha, similar situation. Again, similar situation lang siya. So you need to study, you need to practice solving. Sa practice test na ako sa paper, case 3 ang practice test. So you need to watch the video talaga discussing the case. So, again ha, face-to-face ang quiz. Case 1, case 2, case 3. Problem solving. Show your solution. Sa case 2, wala naman problema. Pwede ra isa ka formula ang ganito. So akong gibuhat na formula. Apply sigtig. Inato lang akong ihatag. Similar lang din siya. Ang kaibahan lang is the given at saka the situation. Okay? Sige, so for documentation purposes, at the count of 3, 1, 2, 3, and smile. Okay, so yes, we will meet pa next meeting. We will discuss the 3 laws of motion. Yes, introduction mas muna tayo sa 3 laws of motion. So, thank you so much, S7, for participating sa ating synchronous discussion this afternoon. Have a nice day, everyone, and goodbye. See you this coming Wednesday for our next synchronous discussion. Goodbye, everyone. Mag-post lang ko sa video.
Hi,
Hi, sir. Thank you, sir.
sir. Thank